everybody. Now we are going to discuss about the examples on resolution of forces. We know that what is the resolution of forces. We have understand that thing in our previous lectures. Resolution of forces having two types, orthogonal resolution and non-orthogonal resolution. Orthogonal resolution is always resolved at 90 degree, means parallel and perpendicular to each other. And in non-orthogonal resolution, the force resolve less than 90 degree or else greater than 90 degree. That resolution is done by parallelogram law of forces, triangle law of forces, as well as Lami's theorem. And we know what is Lami's theorem, that also we have studied. Now let us start with examples of resolution of forces. First, resolve 100 Newton force parallel and perpendicular to axis mm as shown in the figure. This is our mm axis and this is our 100 Newton force. Here the angle between horizontal and mm axis is 45 degree. Angle of this 100 Newton force is theta, and this theta must be calculated from the given slope. So what is happening? Tan theta is equal to 4 by 3, that is 1.33. So theta is equal to 53.13 degree. This is our theta. Now we have to resolve this force parallel to mm axis and perpendicular to mm axis. So whenever the parallel and perpendicular is indicated, then we must have to go through the orthogonal resolution, and that must be calculated with the help of sin theta and cos theta. So here 100 Newton force, whenever it is going to parallel to mm axis, that is 100 cos alpha, and perpendicular, that is 100 sin alpha. So it is our duty to finding out the alpha first. So what is alpha? The total angle between these, that is 180 degree minus this 45 and this theta, we will get the alpha. Now parallel to mm axis is this one force, and perpendicular means exact 90 degree, this force is our second force perpendicular to mm axis. Now the components parallel to mm, that is 100 cos alpha, and that is 14.40 Newton, and component perpendicular to mm axis, that is 100 sin alpha and 100 sin 81.87 degree, that is 98.99 Newton. So this is the simple one, but we have to remember that it is parallel perpendicular or else it is orthogonal and non-orthogonal, that we first have to finding out. Next thing, resolve 100 Newton force shown in the figure along orthogonal axis xx and yy and non-orthogonal axis aa and bb. So this is over 100 Newton force, and orthogonal axis xx and yy means parallel and perpendicular to x axis, that we have to finding out. So it is very much simple. This is 100 cos 30 is parallel to xx, and 100 sin 30 it is parallel to yy. So along xx and yy axis, that we can calculate with the help of cos and sin, but non-orthogonal axis, that is this is our AA axis and this is our BB axis. So, this 100 Newton force must be along with AA axis, that P, and here it is Q, right, that we have to finding out. So, first resolve 100 Newton force along orthogonal axis, that is XX and YY. So, this is 100 Newton force, this is our angle theta, and this is X and this is Y. So, whenever it is moved towards the X, it is cos 30. So, it is 100 cos 30 and this is 100 sin 30. So, component along XX 100 cos 30 and that is 86.60 Newton, and component along YY axis, that is 100 sin 30, it is 50 Newton. Now, resolve 100 Newton force along non-orthogonal axis AA and BB. So, this is our AA axis. So, we are going to consider P force over here, and this is BB axis, and we are going to consider Q axis over there, Q force over there. First, we have to finding out this all angles. This is 20, so it is 70. So, here it is 20 and it is 70. This is 50, then it is 40. So, it is 40 and it is 50. Why we are going to calculate this angle? Because we are going to solve this example using Lami's theorem, and for that we have all the angles. Then what we are going to do? We are always put P and Q over here, and this 100 Newton force, that is our resultant force, it must be opposite of the force. So, this is over here. Now, the angle between the Q and this R, that is 160 degree, this is 70 degree, and here it is 130 degree. Now, from this we can calculate P upon sin 160 is equal to Q upon sin 130 is equal to R upon sin 70. This is our sine rule and this is Lami's theorem. So, we are putting all P upon sin 160 degree is equal to Q upon sin 130 degree is equal to 100 upon sin 70 degree. We are going to take pair of these two, and these two we will get P and Q forces. Clear? Now again, resolve 75 Newton force shown in the figure below along mm and nn axis. This is our mm axis and this is our nn axis, and here it is 75 Newton. What we are going to do? We are always take this as a resultant force and it was take in opposite direction. So, mm axis is our P, this is our Q, and opposite of this, that is R. So, somewhere over here we can calculate this angle as per the our rule. So, what we will get? This is our P, this is Q, and this is R. So, this is our angles. Now, from this basically we can calculate something like this. This is 45, then this is 45. So, opposite of this is 45 and this is again 45. Here it is 60, so it is 30. So, this is 30 and here it is 60. Now, we can calculate 60 and 45. So, it is 105. Here from here to here, what we will get? 120 and here 135 degree. Now, again using Lami's theorem and the sine rule, P upon sin 135 is equal to Q upon sin 120 is equal to 75 upon 105. Now, we can get P and Q from pairing of these two. First, we are going to take pair of this P with R, and second time we are going to take pair of this Q and R. So, we will get our resolution P and Q. Clear? Now, this is the most important thing. Resolution of forces more than two forces. Till today, we are going to consider only the one force, only the two force. In parallelogram, what we have understand, there is two forces P and Q, and we will get resultant force. In a resolution, just we have understand one force, and that is resolved in two direction, and we will get two force. So till today, till this moment, we have just talking about only one or two force, but now we are going to discuss about the more than two forces. So it is very much difficult. We know that resultant is always a single, and it's a direction that we can calculate. But when the number of forces acting on a body on any point, then how we will get the resultant force, that we are going to understand now. So determine magnitude and direction of the resultant force of the force system shown in the figure. Here this is x axis, this is y axis. Here 100 Newton force given, this is 120 Newton, this is 130 Newton with some slope, this is 50 Newton, it is compressive, and this is tensile Newton 100, it is at 60 degree. So whenever we are going to finding out the resultant, we know that we must have to consider all the forces must be tensile. So here 50 Newton is compressive. So first of all, we have to convert this compressive force in tensile force. So P force is somewhere over here. Afterward, this is tensile, this is also tensile, this is also tensile, and it is also tensile. Here they have given the slope. So first we have to finding out this angle with the help of tan theta is equal to 12 upon 5. So theta is equal to 67.38 degree. Now dear student, the most important thing now you have to understand that whenever we are going to calculate the result of all these force on a single axis, then and then we will get the sigma h. So we always take in mind that we are going to resolve all these force on positive x axis. So it is very much simple for us, right? There is no mistake of plus and minus, and there is no mistake of cos and sine. We are always take resolve all the forces on positive x axis, then what we will get, let us see. This is 50 Newton force and it is on a 0 axis. So 50 cos 0, then here 100 cos 60, then 120 cos 90, then this is 130 cos 180 minus 60, 7.38 degree, and this is 100 cos 300 degree. It is most important thing because there is no chance to do mistake. Clear? Now we will get sigma h, 50 cos 0 plus 100 cos 60 plus 120 cos 90 plus 130 cos 112.62 plus 100 cos 30. Here it is always plus and it is with always cos. So we will get sigma h is equal to 100 Newton. Clear everybody? Now sigma v. So just change in this equation, instead of cos we are going to put down sine over there. So it is 50 sine 0, 100 sine 60, 120 sine 90, 130 sine 112.62 and 100 sine 300. So we will get sigma h is sigma v is equal to 240 Newton. Now this is positive, so it is moves towards the right. This is also positive, it is upward. So sigma h over here and sigma v over here. So we will get R in our first quadrant. Clear? Now, what is the value of this R? That we know R is equal to under root of sigma h square plus sigma v square. So, we will get R is equal to under root of 100 square plus 240 square. So, we will get R is equal to 260 Newton. And our next responsibility that we have to finding out the direction of this resultant force, and it is always with the horizontal force. Clear? So, what happening over here that we know? The direction tan theta is equal to sigma v upon sigma h. That is why tan theta is equal to 240 upon 100 in the mode. So, whenever we are going to release this mode, all the sign must be positive. So, theta is equal to 67.38 degree we will get with the sigma h. Clear? It is very much simple, but the thing is that we are going to resolve all the forces about the positive x-axis, then and then it is very much simple for us. Now, the next example, that a system of four forces shown in figure below has resultant 50 Newton. Here resultant is given. Along positive x-axis, determine the magnitude and direction of the unknown force P and theta. Here resultant is given, and what we are going to do? We have to finding out the unknown force and its angle. So, dear student, keep in mind that whenever the resultant is present in our system, then it is automatically in a stable position. So, what happening with this stable position? What happening with this equilibrium? First, that we have to understand. But before that, just consider what they have given. Here 150 Newton force, and the resultant is over here in the same direction. This is our P force, this is 100 Newton force, and this is 200 Newton force, and that force must be resolved on positive x-axis. But what happening with this given resultant force? So, when resultant is present in a system, then system is in equilibrium, means it is stable. It means system is stable. So, if the system is stable, then it can't move in any direction because it is stable. So, resultant is 0, that we know, for the stability only, not for this case. If the system is stable, then we know that it is stable at one point, means there is no movement of resultant force, means it is R0. So, if R is equal to 0, then sigma h and sigma v both 0, then and then R0, right. But when this is happening, when R is equal to unknown for us, system is stable, but we do not know about the R, then R is equal to 0 and sigma h and sigma v is equal to 0. Let us try with some. This is system and it is stable, but we do not know about the R, then sigma h and sigma v both 0. But when the R is present in a system, then it is automatically stable and in equilibrium. But we have to consider this R in sigma h and sigma v. Here R is given in horizontal direction positive. So, sigma h is equal to positive R, but sigma v 0. When the R given, so it is stable, but it is downward, means sigma h 0, but sigma v is equal to minus R, because it is in the direction of minus y direction. So, for the our case, R is present in horizontal x direction positive. So, sigma h is equal to r and sigma v is equal to 0 for our case. So, first we have to finding out sigma h is equal to 50 Newton, this is our r. So, put the value sigma h is equal to 150 cos 0 plus p cos theta plus 100 cos 120 plus 200 cos 240 is equal to 50. We have just resolve this force on positive x-axis. So, we will get p cos theta is equal to 50 from this. Now, sigma v, we know that sigma v is equal to 0, but put the instead of cos sine over there. So, p here sigma v is equal to p sin theta 150 cos 0, 100 sin 120, 200 sin 240 is equal to 0. So, we will get p sin theta is equal to 86.60. Now, p sin theta upon p cos theta is equal to something like this. So, we will get theta from this, that is 60 degree, and put the value of this theta in any equation, we will get p is equal to 100 Newton. Clear? So, from this we can calculate the resolution and the resultant force for the number of forces acting on a body. The other examples we will discuss in our next lecture. Thank you very much.